Welcome back. We're continuing, and now we're talking about chemical reactions in organic chemistry. And to start with, we're going to talk about combustion reaction. Now, combustion reactions occur when substances burn in oxygen. So in this case, we're going to look at how alkanes will burn in oxygen. They would burn in oxygen to produce carbon dioxide and water. And you would realize, or you would know, that alkanes are actually most of them are actually our fuels that we use every day, the petrol that is burnt in cars for them to move. That combustion reaction leads to the production of water and carbon dioxide. In the mornings when you start your car, you'll see water coming out of your exhaust when the car is warming up. That tells you that that combustion reaction is happening, water is being formed, and carbon dioxide is also formed as well. And of course, this is a greenhouse gas, and that is where the whole problem of greenhouse effect and global warming and everything comes in. But let's leave that aside and look at the science behind it for now. Let's look at this now. We're saying that alkanes would undergo combustion reaction, and when they burn in oxygen, we've got carbon dioxide forming and water molecules forming. Okay, that is basic thing that you need to know. Now, as an example, let's say you've got methane there burning in oxygen. You will produce carbon dioxide and water. And remember, you also need to be able to balance your chemical equation. Okay, the next one here is butane burning in oxygen. Look at how you balance it. We know that any alkane burning in oxygen will give us carbon dioxide and water. But when you balance it, you need 10 there, you need 8 there, 13 there, and 2 there. You need to practice this thing. Look at propane burning in oxygen. Try and see if you can be able to balance that. That's a good exercise because you would be required to do so even in your exams. Okay, now, moving on, we also have what we call substitution reaction. Okay, now substitution reaction happens with alkanes because these substances are saturated. In other words, their spaces are filled up. There's no space for them to take things in anymore. So if you want them to change their characters, chemical properties, you would need to substitute what they have with something else, replace what they have with something else. And here I've wrote hydrolysis here as an example of a substitution reaction. Hydrolysis means you're splitting the water molecule. Let's just have a look at something here. If I've got a chloroalkane, okay, like this. This is also substitution reaction because you don't have a double bond. This is saturated. Okay, if you've got ethane, a chloroethane like that, and you add, say, the water molecule there, what are you going to form? You're going to form this. This is going to be replaced by the OH. So this OH there comes down there. Okay, so you've got the OH there. You still have your hydrogen there. Hydrogen. Now, where did the Cl go? It comes to attach itself to that hydrogen there. So this is hydrolysis. It's substitution, but specifically hydrolysis because you have split up that water molecule. Okay, coming to addition reactions. Addition reactions occur with alkenes and alkynes. Why? Because these ones are unsaturated. In other words, they still have spaces, they can take more. Let's look at this hydrogenation here. Hydrogenation means you are adding hydrogen. That's where the word hydrogenation comes from. So adding hydrogen, let's see what would happen. You're starting with a saturated molecule. Okay, so let's say ethene like that. Okay, so When you do that, you are adding hydrogen. Hydrogenation means you're bringing in hydrogen. Hydrogen is H2, so it's HH like that. That bond breaks up, and what do you form here? Let's have a look at it. Then you have got those two spaces open like that. You still have that hydrogen, this one, and that one. So when this one breaks up there, one hydrogen goes there, another one comes in there, and therefore you move from an alkene to an alkane because this is ethane. Okay. Next one, addition reaction. An example again, this one is a hydrohalogenation. This means you're adding hydrogen and you're also adding a halogen, and the halogen could be chlorine, for example. So let's have a look at this. So you've got, say you've got ethene again, okay, and then you add halogenation, so you're adding a hydrogen and a chlorine, for example. What are you going to have? The same thing like we had before happens. That bond there breaks up. You've got an open space there. The hydrogen can go there, the chlorine there, and then you have your hydrogens like that. Okay, and therefore you have formed a chloroethane like that. Right, so that is how hydrohalogenation occurs, and we'll continue with other types of reactions. See you next time.